1. Introduction 1 to 2W, CCSM 3 and 4. Introduction, what is computer security and what to learn? Questions answers. Long answer type and medium answer type questions. K1.1. Explain briefly computer security. How you will design the policies for information security within an organization. Answer. 1. Computer security is the protection of information systems from theft or damage to the hardware, software, and to the information on them. 2. It includes controlling physical access to the hardware, as well as protecting against harm that may come via network access, data, and code injection, and due to malpractice by operators. We can design the policies for information security within an organization by providing 1. Confidentiality. Only authorized users can access the data resources and information. 2. Integrity. Only authorized users should be able to modify the data when needed. 3. Availability. Data should be available to users when needed. 4. Authentication. Communicating with the authorized. K1.2. Which components of the computer system need to be secure? Answer. The components of a computer system that needs to be protected are 1. Hardware, the physical part of the computer, like the system memory and disk drive. 2. Firmware, permanent software that is etched into a hardware device's non-volatile memory and is mostly invisible to the user. 3. Software, the programming that offers services, like operating system, word processor, internet browser to the user. K1.3. Discuss the goals of computer security system. Computer system security 1 to 3W, CCSM 3 and 4. Answer. Computer security has 3 main goals. 1. Confidentiality, making sure people cannot acquire information they should not, keeping secrets. 2. Integrity, making sure people cannot change information they should not, protecting data. 3. Availability, making sure people cannot stop the computer from doing its job. K1.4. Describe the problems related with computer security. Answer. Problems related with computer security are 1. Phishing. Phishing is an attempt to obtain user-sensitive information, including credit card details and banking information, by disguising as a trustworthy entity in an online communication, email, social media, etc. 2. Vishing. Vishing, voice phishing, is an attempt of fraudsters to persuade the victim to deliver personal information or transfer money over the phone. 3. Smishing. Smishing, SMS phishing, is any case where sent text messages attempt to make potential victims pay money or click on suspicious links. 4. Farming. A farming is a cyber attack meant to redirect a website's traffic to another, fake one. B. Farming can be done either by changing the host's file on a victim's machine or by exploiting a flaw in DNS server software. C. In farming, no conscious user interaction is required. 5. Vulnerability. A. Vulnerability is a software mistake that enables a bad actor to attack a system or network by directly accessing it. B. Vulnerabilities can permit an attacker to act as a super user or even a system admin and granting them full access privileges. 6. Exposures. A. It provides a malicious actor with indirect access to a system or a network. B. An exposure could enable a hacker to harvest sensitive information in a secret manner. Introduction 1 to 4W, CCSM 3 and 4. K1.5. Explain security measure taken to protect the system. Answer. To protect the system, security measures can be taken at the following levels. 1. Physical. A. The sites containing computer systems must be physically secured against armed and malicious intruders. B. The workstations must be carefully protected. 2. Human. A. Only appropriate users must have the authorization to access the system. B. Phishing, collecting confidential information, and dumpster diving, collecting basic information so as to gain unauthorized access, must be avoided. 3. Operating system. The system must protect itself from accidental or purposeful security breaches. 4. Networking system. A. Almost all of the information is shared between different systems via a network. B. Intercepting these data could be just as harmful as breaking into a computer. C. Henceforth, network should be properly secured against such attacks. K1.6. How can an organization protect its computer system hardware? Answer. 5 steps to protect computer system hardware are 1. Install firewall. A. A firewall enacts the role of a security guard. B. A firewall is the first step to provide security to the computer. It creates a barrier between the computer and any unauthorized program trying to come in through the internet. 2. Install antivirus software. A. Antivirus is a software that helps to protect the computer from any unauthorized code or software that creates a threat to the system. B. Unauthorized software includes viruses, keyloggers, trojans, etc. Computer system security 1 to 5W, CCSM 3 and 4. C. This might slow down the processing speed of our computer, delete important files, and access personal information. 3. Install anti-spyware software. A. Spyware is a software program that collects personal information or information about an organization without their approval. B. This information is redirected to a third-party website. C. Anti-spyware software is solely dedicated to combat spyware. D. Anti-spyware software offers real-time protection. E. It scans all the incoming information and helps in blocking the threat once detected. 4. Use complex and secure passwords. A. For maintaining system security, we have to use strong and complex passwords. B. Complex passwords are difficult for the hackers to find. 5. Check on the security settings of the browser. A. Browsers have various security and privacy settings that we should review and set to the level we desire. B. Recent browsers give us ability to tell websites to not track our movements, increasing our privacy and security. K1.7. What are the advantages and disadvantages of computer security? Answer. Advantages of computer security. 1. Protect system against viruses, worms, spyware, and other unwanted programs. 2. Protection against data from theft. 3. Protects the computer from being hacked. 4. Minimizes computer freezing and crashes. 5. Gives privacy to users. Disadvantages of computer security. 1. Firewalls can be difficult to configure correctly. 2. Makes the system slower. 3. Need to keep updating the new software in order to keep security up to date. 4. Could be costly for average user. Introduction 1 to 6W, CCSM 3 and 4. K1.8. Write short note on security policy used for computer systems. Answer. General policies. 1. This is the policy which defines the rights of the staff and access level to the systems. 2. It is included even in the communication protocol as a preventive measure in case there are any disasters. Server policies. 1. This defines who should have access to the specific server and with what rights. 2. It also includes which software should be installed, level of access to internet, how they should be updated. Firewall access and configuration policies. 1. It defines who should have access to the firewall and what type of access, like monitoring, rules change. 2. It also includes which ports and services should be allowed. Backup policies. 1. It defines who is the responsible person for backup, what should be the backup, where it should be backed up, how long it should be kept, and the frequency of the backup. VPN policies. 1. These policies generally go with the firewall policy. It defines those users who should have a VPN access and with what rights. 2. For site-to-site connections with partners, it defines the access level of the partner to our network, type of encryption to be set. K1.9. Discuss different security models in details. Answer 1. The Bell-LaPadula model, BLP. A. It is a state machine model used for enforcing access control in government and military applications. B. This model is a formal state transition model of computer security policy that describes a set of access control rules which use security labels on objects and clearances for subjects. C. Security labels range from the most sensitive down to the least sensitive. Computer System Security 1 to 7W, CC 3 and 4. D. The Bell-LaPadula model is an example of a model where there is no clear distinction between protection and security. 2. The BIBA model, a BIBA integrity model, is a formal state transition system of computer security policy that describes a set of access control rules designed to ensure data integrity. B. Data and subjects are grouped into ordered levels of integrity. The model is designed so that subjects may not corrupt data in a level ranked higher than the subject, or be corrupted by data from a lower level than the subject. C. This model was developed to address integrity as the core principle, which is the direct inverse of the Bell-LaPadula model. 3. The Brewer and Nash model, a. It was constructed to provide information security access controls that can change dynamically. B. This security model, also known as the Chinese wall model, was designed to provide controls that mitigate conflict of interest in commercial organizations and is built upon an information flow model. C. In the Brewer and Nash model, no information can flow between the subjects and objects in a way that would create a conflict of interest. D. This model is commonly used by consulting and accounting firms. K1.10. What are the advantages and disadvantages of BIBA model? Answer. Advantages. 1. It's simple and easy to implement. 2. It provides a number of different policies that can be selected based on need. Disadvantages. 1. The model does nothing to enforce confidentiality. 2. The BIBA model does not support the granting and revocation of authorization. 3. To use this model, all computers in the system must support the labeling of integrity for both subjects and objects. So there are problems with using the BIBA model in a network environment. K1.11. Discuss the security mechanism used to provide security in computer system. Introduction 1 to 8W, CC 3 and 4. Answer. Security mechanisms used to provide security in computer system are 1. Encipherment. A. Encipherment is an algorithm used for performing encryption or decryption by converting information from plaintext to ciphertext. B. Cryptography and steganography are used for enciphering. 2. Data integrity. A. Data integrity is the maintenance and the assurance of the accuracy of the data over its entire lifecycle. B. Data integrity is preserved by comparing check value received to the check value generated. 3. Digital signature. A. A digital signature is a means by which the sender can electronically sign the data, and the receiver can electronically verify the signature. B. Public and private keys can be used. 4. Authentication exchange. In authentication exchange, two entities exchange some messages to prove their identity to each other. 5. Traffic padding. Traffic padding means inserting some fake data into the data traffic to prevent the unauthorized attempt to use the traffic analysis. 6. Routing control. Routing control means selecting and continuously changing different available routes between sender and receiver to prevent the opponent from eavesdropping on a particular route. 7. Notarization. A. Notarization means selecting a third trusted party to control the communication between two entities. B. The receiver can involve a trusted third party to store the sender request in order to prevent the sender from later denying that they made a request. K1.12. What are the components of security policy? Answer. Following are the components of security policy. 1. Training. A strong training program that is contextually appropriate for each position gives staff members the knowledge they need to understand and properly respond to cyber threats. 2. Passwords. Strong passwords is a line of defense especially when hackers are trying to force their way into your network. Computer System Security 1 to 9W, CC 3 and 4. 3. Mobile devices. A. Many companies have bring your own devices, BYOD, policies to manage and track the mobile devices brought in by employees. B. These policies set expectations for which devices employees can use the security these devices require, and how the data on these devices will be managed. 4. Internet use. A. Certain types of internet usage can put our organization at a higher cybersecurity risk. B. To prevent this risk, write clear policies that define how employees may use the internet, what types of content should be avoided, and what devices should be used to do so. 5. Social media. A. Hackers can leverage social media to distribute malware and gain access to user accounts. B. In particular, the messenger functionality associated with many of these networking sites provides a convenient way for attackers to send compromised files or misleading messages. Sample attacks, the marketplace for vulnerabilities, Error 404 Hacking Digital India Part 1 Chase. Part 2. Questions answers. Long answer type and medium answer type questions. K1.13. Discuss various attacks in computer security. Answer. Various attacks in computer security. 1. Malware. A. Malware is used to describe malicious software, including spyware, ransomware, viruses, and worms. B. Malware breaches a network through vulnerability typically when a user clicks a dangerous link or email attachment that then installs risky software. 2. Macroviruses. A. These viruses infect applications such as Microsoft Word or Excel. Introduction 1 to 10W, CC 3 and 4. B. Macrovirus is attached to an application's initialization sequence. C. When the application is opened, then virus executes instructions before transferring control to the application. D. The virus replicates itself and attaches to other code in the computer system. 3. File infectors. A. File infector viruses usually attach themselves to executable code, such as .exe files. B. The virus is installed when the code is loaded. 4. System or boot record infectors. A. A boot record virus attaches to the master boot record on hard disks. B. When the system is started, it will look at the boot sector and load the virus into memory, where it can propagate to other disks and computers. 5. Stealth viruses. A. Stealth viruses take over system functions to conceal themselves. B. They do this by compromising malware detection software, so that the software will report an infected area as being uninfected. C. These viruses conceal any increase in the size of an infected file or changes to the file's date and time of last modification. 6. Trojans. A. A Trojan is a program that hides in a useful program and has a malicious function. B. A major difference between viruses and Trojans is that Trojans do not self-replicate. 7. Logic bombs. A logic bomb is a type of malicious software that is appended to an application and is triggered by a specific occurrence, such as a logical condition or a specific date and time. 8. Worms. A. Worms differ from viruses in that they do not attach to a host file, but are self-contained programs that propagate across networks and computers. B. Worms are commonly spread through email attachments. Opening the attachment activates the worm program. 9. Droppers. A dropper is a program used to install viruses on computers. In many instances, the dropper is not infected with malicious code, and therefore might not be detected by virus scanning software. Computer System Security 1 to 11W, CC 3 and 4. B. A dropper can also connect to the internet and download updates to virus software that is resident on a compromised system. 10. Ransomware. Ransomware is a type of malware that blocks access to the victim's data and threatens to publish or delete it unless a ransom is paid. 11. Denial of service attack. A denial of service attack floods systems, servers, or networks with traffic to exhaust resources and bandwidth. B. As a result, the system is unable to fulfill legitimate requests. Attackers can also use multiple compromised devices to launch this attack. C. This is known as a distributed denial of service, DDoS, attack. K1.14. Write short note on server-side attack and insider attack. Answer server-side attacks. 1. Server-side attacks are launched directly from an attacker, the client, to a listening service. 2. Server-side attacks seek to compromise and breach the data and applications that are present on a server. 3. Server-side attacks exploit vulnerabilities in installed services. Insider attacks. 1. An insider attack is a malicious attack executed on a network or computer system by a person with authorized system access. 2. Insiders that perform attacks have a distinct advantage over external attackers because they have authorized system access and also may be familiar with network architecture and system policies/procedures. 3. In addition, there may be less security against insider attacks because many organizations focus on protection from external attacks. K1.15. Differentiate between active and passive attack. Introduction 1 to 12W, CCSM3 and 4. Answer. Basis for active attack passive attack comparison. K1.16. Write a short note on marketplace for vulnerabilities. Answer 1. Vulnerable consumers fail to understand their preferences and lack the knowledge, skills, or freedom to act on them. 2. To protect them, we can censor information, restrict choices, and mandate behaviors. 3. 1/5 of the public is functionally illiterate, and substantial majority of consumers, adolescents included, appear to be marketplace literate. 4. Rather than curtail consumer prerogatives to protect a vulnerable minority, education reform focused on the values, knowledge, and skills necessary to create and navigate responsive markets should be developed. 5. Reformed adult and adolescent education can refine, expand, and accelerate learners' informal and experiential understanding of marketplace fundamentals. 6. The aim is to significantly replace trial and error with a robust understanding of markets habitually governed by social virtues. Basic. Modification in the information harm to the system. Threat 2. Attack awareness. Task performed by the attacker. Emphasis is on. Active attack tries to change the system resources or affect their operation. Occurs. Always causes damage to the system integrity and availability. The entity, victim, gets informed about the attack. The transmission is captured by physically controlling the portion of a link detection. Passive attack tries to read or make use of information from the system, but does not influence system resources. Does not take place. Do not cause any harm. Confidentiality. The entity is unaware of the attack. Just need to observe the transmission. Prevention. Computer system security 1 to 13W, CCSM3 and 4. 7. Evidence suggests that these aims can be better achieved via adolescent choice and should be the focus of adult basic education reform. K1.17. How can we defend zero-day vulnerabilities? Answer. 1. A zero-day vulnerability is a computer software vulnerability that is unknown to or unaddressed by those who should be interested in mitigating the vulnerability, including the vendor of the target software. 2. Until the vulnerability is mitigated, hackers can exploit it to adversely affect computer programs, data, additional computers, or a network. 3. An exploit directed at a zero-day is called a zero-day exploit or zero-day attack. 4. The term zero-day referred to the number of days since a new piece of software was released to the public. So, zero-day software was software that had been obtained by hacking into a developer's computer before release. 5. The term was applied to the vulnerabilities that allowed this hacking, and to the number of days that the vendor has had to fix them. 6. Once the vendor learns of the vulnerability, the vendor will usually create patches or advise workarounds to mitigate it. 7. The more recently that the vendor has become aware of the vulnerability, the more likely that no fix or mitigation has been developed. 8. Even after a fix is developed, the fewer the days, the higher the probability that an attack against the afflicted software will be successful because not every user of that software will have applied the fix. 9. For zero-day exploits, unless the vulnerability is inadvertently fixed, for example, by an unrelated update that happens to fix the vulnerability, the probability that a user has applied a vendor-supplied patch that fixes the problem is 0, so the exploit would remain available. Zero-day attacks are a severe threat. K1.18. Discuss Error 404 Hacking Digital India Part 1 Chase. Answer. 1. In Error 404 Hacking Digital India Part 1 Chase, the cybercrime and cyber attacks hack the information of users like bank detail and personal information. 2. It is real-time incident. In this, attacker or hacker creates an attractive video so that victim gets attracted and plays that video into system. 3. When we clicked on video to play, then at the time of buffering, hacker can know our current location and GPS history, but also have complete access to our contacts, text messages, Facebook, WhatsApp, and most importantly our bank details, including our CVV number. Introduction 1 to 14W, CCSM3 and 4. 4. Hackers are creating a kind Trojan file and Android APK files. The APK files that will be distributed all over the internet. Those who download this file will be hacked easily. 5. Potential cyber attacks that is most common in Error 404 hacking. A. Web application attacks. A web application is a client-server computer program which uses web browsers and web technology to allow its visitors to store and retrieve data from the database over the internet. 2. If there is flaw in the web application, it allows the attacker to manipulate data using SQL injection attack. B. Network security attacks. Network security attacks are unauthorized actions against private, corporate, or governmental IT assets in order to destroy them, modify them, or steal sensitive data. 2. As more enterprises invite employees to access data from mobile devices, networks become vulnerable to data theft or total destruction of the data or network. C. Mobile security attacks. Mobile security, or mobile device security, has become increasingly important in mobile computing. 2. The security of personal and business information now stored on smartphones. 3. More and more users and businesses use smartphones to communicate, but also to plan and organize their users' work and also private life. 4. Within companies, these technologies are causing profound changes in the organization of information systems, and therefore they have become the source of new risks. V. Indeed, smartphones collect and compile an increasing amount of sensitive information, to which access must be controlled to protect the privacy of the user and the intellectual property of the company. Control hijacking. More control hijacking attacks integer overflow. More control hijacking attacks format string vulnerability. Part 3. Questions answers. Long answer type and medium answer type questions. Computer system security 1 to 15W, CCSM3 and 4. K1.19. Discuss control hijacking in computer security. Answer 1. Hijacking is a type of network security attack in which the attacker takes control of a communication. 2. In hijacking, also known as a man-in-the-middle attack, the perpetrator takes control of an established connection while it is in progress. 3. The attacker intercepts messages in a public key exchange, and then retransmits them, substituting their own public key for the requested one, so that the two original parties still appear to be communicating with each other directly. 4. The attacker uses a program that appears to be the server to the client, and appears to be the client to the server. 5. This attack may be used simply to gain access to the messages, or to enable the attacker to modify them before retransmitting them. 6. Attacker's goal in control hijacking. A. Take over target machine, for example web server. B. Execute arbitrary code on target by hijacking application control flow. 7. There are 3 types of control hijacking in computer security. A. Buffer overflow attacks. B. Integer overflow attacks. C. Format string vulnerabilities. K1.20. Describe briefly buffer overflow attack. Or what is control hijacking with an example? Explain the term of buffer overflow and control hijacking. AKTU 2019-20, Marks 10. Answer control hijacking. Refer 1 Quetzal and 19 centavos, page 1, 15W, Unit-1. Buffer overflow and control hijacking. 1. Buffers are memory storage regions that temporarily hold data while it is being transferred from one location to another. 2. A buffer overflow, or buffer overrun, occurs when the volume of data exceeds the storage capacity of the memory buffer. 3. As a result, the program attempting to write the data to the buffer overwrites adjacent memory locations. 4. Attackers exploit buffer overflow issues by overwriting the memory of an application. This changes the execution path of the program, triggering a response that damages files or exposes private information. Introduction 1 to 16W, CC-SM3 and 4. 5. Following are the types of buffer overflow attacks. A. Stack-based buffer overflows. These are more common and leverage stack memory that only exists during the execution time of a function. B. Heap-based attacks. These are harder to carry out and involve flooding the memory space allocated for a program beyond memory used for current runtime operations. K1.21. How to prevent buffer overflow attack. Answer buffer overflow attack can be prevented using 1. Address space randomization, ASLR. A. It randomly moves around the address space locations of data regions. B. Buffer overflow attacks need to know the locality of executable code, and randomizing address spaces makes this virtually impossible. 2. Data execution prevention. A. It flags certain areas of memory as non-executable or executable, which stops an attack from running code in a non-executable region. 3. Structured exception handler overwrite protection, SHAP. A. It helps to stop malicious code from attacking structured exception handling, SEH, a built-in system for managing hardware and software exceptions. B. It prevents an attacker from being able to make use of the SEH overwrite exploitation technique. C. At a functional level, an SEH overwrite is achieved using a stack-based buffer overflow to overwrite an exception registration record stored on the thread stack. K1.22. Explain integer overflow attack. Answer 1. An integer overflow attack occurs when an attacker causes a value in the program to be large enough to overflow unexpectedly. 2. A common form of this attack is to cause a buffer to be allocated that is too small to hold data copied into it later, thus enabling a buffer overflow attack. 3. We are able to detect buffer overflow attacks in the same way as a normal buffer overflow attack. 4. An integer overflow is the condition that occurs when the result of an arithmetic operation, such as multiplication or addition, exceeds the maximum size of the integer types used to store it. Computer System Security 1 to 17W, CC-SM3 and 4. 5. When an integer overflow occurs, the interpreted value will appear to have wrapped around the maximum value and started again at the minimum value, similar to a clock that represents 13:00 by pointing at 1:00. K1.23. How can we prevent integer overflow attack? Answer integer overflow can be prevented by 1. Avoidance. A. By allocating variables with data types that are large enough to contain all values that may possibly be computed and stored in them, it is always possible to avoid overflow. B. Static analysis tools and formal verification techniques can be used to ensure that overflow does not occur. 2. Handling. A. If it is anticipated that overflow may occur, then tests can be inserted into the program to detect when it happens and do other processing to mitigate it. 3. Propagation. A. If a value is too large to be stored, it can be assigned a special value indicating that overflow has occurred. B. This is useful so that the problem can be checked for once at the end of a long calculation rather than after each step. C. This is often supported in floating point hardware called FPUs. K1.24. What do you understand by format string vulnerabilities? Answer. 1. A format string vulnerability is a bug where user input is passed as the format argument to printf, scanf, or another function in that family. 2. The format argument has many different specifies, which could allow an attacker to leak data if they control the format argument to printf. Since printf and scanf are variadic functions, they will continue popping data off of the stack according to the format. 3. For example, if we can make the format argument %x, 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 printf will pop off 4 stack values and print them in hexadecimal, potentially leaking sensitive information. 4. Printf can also index to an arbitrary argument with the following syntax, %n$x, where n is the decimal index of the argument we want. K1.25. How can we prevent format string vulnerabilities? Introduction 1 to 18W, CC-SM3 and 4. Answer. Preventing format string vulnerabilities. 1. Always specify a format string as part of program, not as an input. Most format string vulnerabilities are solved by specifying %s as format string and not using the data string as format string. 2. Make the format string a constant. 3. If the above 2 practices are not possible, use defenses such as format_guard. Defense against control hijacking platform defense, defense against control hijacking runtime defense, advanced control hijacking attacks. Answer type questions. K1.26. How can we control hijacking attack? Answer. Hijacking attack is controlled through platform defense. Through platform defense, we can prevent target machine by using 1. Fix the bug. A. Audit software through automated tools. B. Rewrite software in a safe language. C. Concede overflow, but prevent code execution. D. Add runtime code to detect overflows exploits. I. Halt process when overflow exploit detected. 2. Stack guard 2. Marking memory as non-execute. A. Prevent attack code execution by marking stack and heap as non-executable. 2. Runtime defense. 1. In runtime defense, we test for stack integrity. 2. We embed canaries in stack frames and verify their integrity prior to function return. There are 2 types of canaries. Local canary SFP ret str. Local canary SFP ret str top of stack. Frame 2 Frame 1. Fig. 1.26.1. Computer System Security 1 to 19W, CC-SM3 and 4. A. Random canary. I. In random canary, random string is chosen at program startup. 2. Insert canary string into every stack frame. 3. Verify canary before returning from function. A. Exit program if canary changed. B. Turns potential exploit into dose. 4. To corrupt, attacker must learn current random string. B. Terminator canary. I. String functions will not copy beyond terminator. 2. Attacker cannot use string functions to corrupt stack. 3. Heap protection. A. It protects function pointers and set jump buffers by encrypting them. B. It has less effective and more noticeable performance effects. K1.27. Explain heap spray attack with its techniques. Answer. A. Heap spraying is a technique used in exploits to facilitate arbitrary code execution. B. In heap spray attack, we put number of copy of exploit, shell, code in various places of heaps. C. It is reliable method for exploiting heap overflows as shown. PTR. Data. FP1, FP2, FP3. Object T. Of table. Method number 1, method number 2, method number 3. Fig. 1.27.1. D. After overflow of buffer. Fig. 1.27.2. PTR data. Object T. Buff. 256. Shell code. Of table. E. Here, attacker does not know where browser places shellcode on the heap. Following are the techniques used in heap spray attack. 1. Heap spraying. A. Use JavaScript to spray heap will shellcode. B. Then point table PTR anywhere in spray area. C. Pointing func PTR almost anywhere in heap will cause shellcode to execute. 2. Vulnerable buffer placement. A. Placing vulnerable buff. 256. Next object O. I. By sequence of JavaScript allocations and freeze make heap look as follows. Object O. Free blocks. Fig. 1.27.4. 2. Allocate buffer in JavaScript and cause overflow. 3. Successfully used against a Safari PCRE overflow. Heap spray control hijacking can be prevented as 1. Protect heap function pointers. 2. Better browser architecture. A. Store JavaScript strings in a separate heap from browser heap. B. OpenBSD heap overflow protection. C. Detect sprays by prevalence of code of heap.